Thank you all for coming to this late talk. I'm fully aware that I'm between you and your evening. So what I did is I crammed all of the OWASP projects that I could fit in this presentation. And I'm going to rush through it, I hope. But this is my talk, 10 top OWASP projects beyond the OWASP top 10. Who am I? I am Bram Patelski. I work at Sopasteria, formerly known as Ordina. I do a lot of things with Java. I'm in Java so long that I even am Sun certified Java developer or Java programmer and web component developer. But I do a lot with security, as you can see. If you want to know more, my LinkedIn profile is at the bottom, but that's not probably not why you're here. The agenda for today, I'm going to give an introduction to OWASP. What is the organization? The main part of this talk is 10 key OWASP projects. And then, because it's quite a lot, I'm going to show you where to start and then come to a conclusion. And if there's time left, questions and answers. So before we start into OWASP, I'm going to quickly recap what is shifting left. We've got this nice software development lifecycle. And we all know that the earlier you find your vulnerabilities or your issues, the easier it is to fix them. Later in the process, more complex to change, to add changes and fix things. So we want to discover things early. So with security issues, it's the same thing. So we need to do some security testing. And what we often see is we do that about a day, maybe 2 days before we go live. We do a pen test, and then we need to fix stuff. So we do that like this. Now, if we fix bugs like this, then you know what will happen in production. We need to do this. And I don't want to be this guy, because I want to fix things early when there's time enough to fix things properly. So what is shifting left? Shifting left is actually doing security throughout the software development lifecycle. Not all the way at the beginning, not just at the beginning, all the way through the development lifecycle. And there are a few examples here. There are more, obviously. This is what shifting security left is. Now, what is OWASP and what does it have to do with security? OWASP, formerly called the Open Web Application Security Project, but it's not all about web anymore. So it's now called the Open Worldwide Application Security Project. They aim to be a global open community that empowers secure software through education tools and collaboration. That's a whole mouthful, but basically it comes down to their goal: no more insecure software. They were introduced in 2001. It is a non-profit organization, so it aligns perfectly with Java and open source. All of their projects are open source, either open source, Creative Commons, but all of them are free to use, royalty free. They are financed through, well, they're not really financed. They are. You can have a partnership, you can have a membership, but all of the work, most of the work that they do, is volunteer work. So throughout, oh, this doesn't work, unfortunately. I had some icons here. That's too bad. There will be some icons on the right, I hope, denoting flagship projects or production projects. These are the main projects that OWASP gives. I now know why, no internet. The flagship projects are the most familiar projects in OWASP. They are like the OWASP top 10 that you know, and a number of other well-known OWASP projects. Production projects are just as mature as flagship projects. They are a little bit less known. Then we have lab projects. Lab projects are a bit more mature than incubator projects. Incubator projects are just starting up and not really mature. There are a few projects that need website updates. There are projects that are purely for documentation. There are projects that supply you with a tool. It's an alarm? I don't know. There are some projects that define a standard. Some projects target audience like a builder, either a breaker or a defender, and all of my slides have a link to the project. I'm sorry about the icons, they don't work because I forgot to download awesome fonts to my laptop. In total, there are about 350 projects, so there's a lot to choose. Now, obviously, we do have to address the project that most of you know very well, the OWASP Top 10. Why is this the OWASP Top 10? We'll see in a minute. The OWASP Top 10 is actually the OWASP Top 10 Web Application Security Risks. It has 7 releases. The 8th release is very soon, in the first half of next year. They are welcoming more test data so they can improve the list up to December of this year. All of the items on the list are denoted with the letter A, a number, which is the position in the top 10, and the year of the top 10. This project was started in 2003 based on a bug report for an online cinema ticketing system, which is very fitting, being here in Pathé. The bug in question was caused by the fact that this was a Java-based application, and Java does not have an unsigned int. So the fun thing that you could do in this ticketing ordering system was order a bunch of cinema tickets, some popcorn, some drinks, and -5 tickets for another movie. Total sum to pay €0 or dollars, fun things. Now that started the OWASP Top 10. Very important, all of the OWASP Top 10s are awareness tools. There is no such thing as we are compliant to the OWASP Top 10. That simply doesn't make sense. Now, those of you who are paying attention, yes, this is 1.1. Why is this 1.1? There are multiple top 10s, and I made a top 10 of top 10s. So, spoiler alert, I have more than 10 projects in this deck. Let's go for the second top 10. This is the top 10 of mobile application risks. It was first released in 2014. The format is simply the letter M for mobile plus a number. Somehow they didn't add the year. And it was updated in 2016 and 2024. Then there's the API Security Risks Top 10, first released in 2019 and updated last year. And this deals with APIs because web applications and mobile applications often have a backend API that they talk to. Then there is the CI/CD security risks. You develop your software, you probably release it, build it, and release it in a CI/CD pipeline. So that's where the CI/CD pipeline, CI/CD security risks top 10 comes into play. You see the formatting again, very recognizable, CI/CD sec plus a number. Only a single release 2 years ago. Then we need to obviously run our applications. We do that in containers. So there's the Kubernetes top 10 with Kubernetes risks. There's, again, a single release in 2022. Numbering is clear. And we do that in containers. Docker top 10. This is a work in progress. It was active in 2019 through 2021. Since that, then it's a bit stale, unfortunately. So this is probably an incubator project. I will post the slides online and you can see all the icons and see the status of each project. Then there's a Cloud Native App Top 10, CNAS, single release in 2022. There is a Low Code and No Code Top 10, 2022 as well. I think it's not a coincidence that this was in the middle of COVID. Something new is the Smart Contract Top 10. So this one deals with Web3, blockchain and stuff like that. There is also a Solana Top 10 initiated in January of this year. There were some documents released on the GitHub but nothing official, and it's been stale. It's been active through February to April this year. So I'm not sure if that will actually be a active project. But there is a smart contract top 10. And the final top 10 that I want to mention is not really a top 10 of risks or vulnerabilities, but the top 10 of proactive controls. Now, we saw a number of top 10s of things you shouldn't do. This is a top 10 of things that you should do. Again, this is not something that you can be compliant to. The most recent top 10 obviously is your first starting point, but if you have those in place, feel free to take the other releases, 2018, 2016, 2014, to get some more best practices on what to do in your code. So that's the top 10. We've got one project out of the way, which is the biggest one, namely 10 top 10s. Then there is, and this is a little bit more abstract, the OWASP SOM, which is called full out the Software Assurance Maturity Model. Now, the left side is the most abstract, the governance business model. Let's first explain this graph. The OWASP SOM consists of 5 business functions that you see from left to right. This nicely aligns with the software development lifecycle as well. Each of those business functions consists of 3 aspects, and each aspect has a stream A and stream B on the left and right of each column. Now, each stream in this model also has 3 maturity levels, levels 1, 2, and 3, obviously. So this creates 90 levels that you can achieve. You can use this as a measurement tool and as a roadmap to grow your security maturity. It also has, so nicely, the software development lifecycle underneath. I'll give you an example of one of the aspects. This is the aspect secure build in implementation. Again, in the middle, stream A, on the right is stream B. We talked about today, among others, with Brian Sneak, evaluating dependencies on the right in stream B, doing stuff like OWASP dependency check. Oh, I'm sorry, I'm a little bit ahead of myself, but that's what this stream is about. And in the middle, the build process, actually defining your CI/CD pipeline and automating that is the build process. So there are probably a lot of things that you already do which are part of the OWASP SOM model. Now, if you want to measure how mature you are on the OWASP SOM scale, then you can use documents like these. These are readily available in either Excel or a Google Docs Excel sheet with those 90 questions that you can answer with drop-down boxes to measure how mature am I on a specific scale, on a specific level in the OWASP SOM. Now again, the left-hand side on this slide, the governance part, is pretty abstract, and the scope of governance is organization-wide, company-wide, which is probably not what you're familiar with in your team. Maybe you are. Please go ahead and see if you can answer those questions. Design is a little bit more towards developers, but the most important part that you probably want to focus on is implementation and verification, maybe even operation. So keep that in mind if you dabble into OWASP SOM. There are a number of releases. OWASP SOM was formerly called OpenSOM when it was not part of OWASP yet. In 2016, it was adopted by OWASP, renamed to OWASP SOM, and the most impactful changes happened in 2021 in version 2 when they actually added the design business function, the 5th one. Or actually the 2nd one, they plugged it in between the 1st and the 3rd. Now, there is also a more technical version of OWASP SOM called OWASP DSOM, which stands for the DevSecOps Maturity Model. This one focuses mainly on DevOps, technical aspects like building, deployment, logging, monitoring, stuff like that, but also testing, dynamic testing, static testing, how deep you are testing, etc., stuff like that. Then we're going to talk a little bit about threat modeling. Threat modeling, I'm not sure if everybody knows what threat modeling is, but basically what you do each morning when you wake up, you look at the weather forecast, you see, is it going to be cold, is it the chance of rain, and you dress yourself appropriately. Maybe you want to take an umbrella. That's threat modeling. What are my risks and what can I do to mitigate those risks? You can do that with your software as well. And that's called threat modeling. Now, OWASP Cornucopia is a card game. There is a digital version as well. There's a physical version as well that can help you do threat modeling exercises. Cards reference secure coding practices, the application security verification standard, which we will come to in a second, and more stuff. But the prerequisites of doing threat modeling are you have to know your system. You have to have a data flow diagram. You have to have architectural models to help you pinpoint critical points in your application, which is where 4.2, the OWASP Threat Dragon project comes into play. OWASP Threat Dragon is basically a modeling tool, but you can use something like draw.io as well. You can use a whiteboard, but OWASP Threat Dragon is specifically designed to help you with your data flow diagram and adding trust boundaries, these green lines in between systems. So that's the trust boundaries that you can focus on what can happen there, what risks can I encounter there. On to number 5, this is what I tipped on earlier, the OWASP ASVS. This is a standard. ASVS stands for the Application Security Verification Standard, and this helps you define requirements for your software development practices. How can I make sure that I validate the security and trustworthiness of my application? You can use this as a metric to assess the degree of trust in your web application. You can also use this as a guidance. So it helps you to decide which controls do I want to implement to build a, to define as a, for my application security requirements. But it can also help you, if you buy software, as a procurement tool to help you define security verification requirements for your for contracts when you buy off-the-shelf software. There is also a mobile application security verification standard. It's a long word, MASVS as well. On to number 6. We are probably all developers, so we want to develop and we want to do it the right way. Now, maybe you saw Brian's talk earlier. He talked about Copilot and how Copilot can help you code. The OWASP cheat sheet series is also a document, actually a number of documents that can help you with your coding practices. This is mainly your cheat sheet on, hey, I'm developing an API, I'm developing with Java, I'm developing with OAuth. Actually, there are a number of cheat sheets, quite a number of cheat sheets for just about any topic. Well, not any topic. I did search for a Python cheat sheet. There's none. But we've got Java, mobile application security, NPM, Node.js, .NET, various authentication and credential cheat sheets, CI/CD cheat sheet, etc., etc. Obviously, also the Docker and container stuff as well. Which brings us to the code review guide. So if you're doing peer reviews, like we discussed in the earlier talk with Brian, you want to have it guided. So that's where the code review guide comes in. This document consists of 3 parts. First, it talks about why and how we do code review. Spoiler, manual review is still the most effective way of finding actual issues. I'm not talking about the number of issues, but I'm talking about actual positive findings. So not false negatives, etc. The main part of this document is describing vulnerabilities by type. Yes, it uses the OWASP top 10 for most of the examples. It is a older 2013 top 10 that it uses, because this document was released in 2017. But 8 of those in the 2013 edition are still in the 2021 edition. So it's absolutely relevant. They also discuss a number of other vulnerability types not in the OWASP top 10 of 2013, including many web concepts. Then there's the appendix, and since this document is about 200 pages, I suggest to start with the code review checklist, which is one of the appendixes. There's also a do's and don'ts in the appendix, there's a threat modeling example, and there are examples of code crawling practices. So this is a number of keywords based on your programming languages that you use to search for in your code, Control or Command F through your code to find the interesting parts on the various different checks that you want to do. One of the other well-known projects is OWASP Dependency Check. You may know this. This is basically the tool that you can use for software composition analysis. What dependencies am I using in my code, and are they up to date, or do they contain vulnerabilities? Software composition analysis is a specific type of SAST, or static application security testing, which basically views the static content of your application, the code, or the POM file, and it looks for vulnerabilities in there. There are alternatives, and Brian is not here, but I wanted to mention Sneak. But there's also Sonatypes, Nexus IQ, there is NPM Audit, which you may have used for front-end code and JavaScript code. OWASP Dependency Check creates reports in different formats that you can import into, for instance, your Jenkins or your SonarQube. And those can also be included into OWASP Dependency Track. So this application fetches vulnerability intelligence not just from the NIST NVD, National Vulnerability Database, which also OWASP Dependency Check is based on, but it also gets its intelligence from GitHub advisories, Sonatype open source software index, and VulnDB. It integrates with a number of ecosystems that you can see here. Obviously, Maven and maybe Gradle is the most important part, ones that we probably use. But it not only checks for security vulnerabilities, it also checks for licensing vulnerabilities. If you use a specific open source library, open source license, not all of those are equal, and not all of those give you free rein to do whatever you do when you use a dependency. Some restrict you quite a lot, maybe even force you to open source the code that you use your dependency in as well. And then there's operational risks that it also checks for. For instance, this application has a lot of older dependencies. You might want to update those as well. Now, this is all done using a software bill of material. A software bill of material, or SBOM, is basically the ingredients list of your application. We see more and more that companies require you to supply us an SBOM, which they can then use to define vulnerabilities or specific components. We wished we would have SBOMs for all of our applications when Log4Shell was a thing, but we didn't, and it got a pretty big boost after that. Now, OWASP has a standard called OWASP Cyclone DX, which is a SBOM standard. So if you supply these as you are the producer of software, you improve the trust of your software to the company or the client that you're creating your software for. They can be verified using hashes for integrity and authenticity using signatures, so that you know that a SBOM is supplied by the actual owner of the software. And they can be used to quickly pinpoint vulnerable dependencies, end-of-life dependencies. You can use them to review licenses and obligations, like I said earlier, and to prove provenance, to prove ownership of specific dependencies. There's an alternative standard called SPDX, which is managed by the Linux Software Foundation. And but the Cyclone DX standard supports vulnerability disclosure reports. It supports vulnerability exploitability exchange and a number of SBOM formats, namely the standard software bill of material, but also software as a service bill of material, hardware bill of material, machine learning bill of material, and a number of others. Then we go on to number 8, OWASP ZAP. This is also a project that some people may be familiar. OWASP ZAP is a DAST tool, a dynamic application security testing tool. This not checks your static code, but it checks your running application. That's the main difference between DAST and SAST. OWASP ZAP actually stands for the Z attack proxy. It is a proxy application that basically man-in-the-middles your application. It's an application that sits between you, the client, and the server side, that can be used to manipulate requests, to monitor requests, etc. It has a GUI, like you see here, but it can also be injected in your CI/CD pipeline to use it as an automated tool on the fly. Then, so we've got all these reports. We talked about OWASP ZAP. We talked about OWASP dependency check. Brian showed us Burp Suite. We've got actual SAST tools that specifically target security vulnerabilities like Fortify, Aqua Trivi, Nexus Lifecycle with dependencies. We've got SonarQube for all our generic quality assurance, Git leaks for scanning for secrets, Azure Security Center, and lots of others. And my team manages a number of applications. So if I have all of these scanning tools and I have all of these vulnerabilities and lots of applications to scan for, I need to check dozens of dashboards, which I don't like. So what I want to do is just put them all in one single dashboard, which is basically Defect Dojo is the elastic stack, not for logging, but for findings. So all of my quality assurance project reports can be put in here. Yes. Now, I've got here on stage this nice Lego box, which we'll come to in a minute, but it looks, actually I did my best to make it look a lot like this logo. This is the logo of the OWASP JuShop project. The OWASP JuShop project has a goal to be an awareness tool for developers, and it is stuffed with vulnerabilities. 100+ vulnerabilities and challenges built into a vulnerable web shop. It's built with Node.js, Express, and Angular, so there's no Java, but it doesn't need to. There are plenty of vulnerabilities to find. The 100+ challenges are all spread over the entire OWASP top 10. There is the actual vulnerability that started the OWASP top 10, the unsigned integer vulnerability, but there are also some more modern challenges on, for instance, on Web3, NFTs, and crypto, which are really cool. We did a test. We found some Ethereum. We thought we had found 4,000 euros, but unfortunately that was on the testnet, so it was it had no value. And the cool part of this project is it runs almost everywhere. Almost all OSs, it runs in the cloud, it runs on Kubernetes, it runs on web servers, and more. Here's a graph that shows the divide on which vulnerabilities that it contains. So basically something in each category that you can think of. Again, the OWASP Top 10, web application security risks, the API security risks. It has a number of privacy risks. It has topics from the OWASP ASVS, the Application Security Verification Standard, and more. So what the cool thing is with this project is that you can use it as a sort of capture the flag event, as an awareness event to learn developers how to hack an application. So that's what we did with a side project called the multi-user project, which is basically a multi-tenant JUshop infrastructure that you can run. It also contains a leaderboard and admin panels to either delete or restart specific instances. It runs on most OSs, cloud, Kubernetes, web servers, and more, including an actual cluster, a physical cluster of 4 Raspberry Pis that you obviously store in a nice server case. Actually, last year I talked to the leads of this project, and they asked, is there someone who is good at building with Lego and could design a server case with Lego in the form of our logo? After the talk, I went to them. I said, what's actually your idea? How does it work? Who is going to pay for the bricks? Luckily, my manager said, ooh, that sounds like a nice thing. What will it cost? Okay, why don't you build one as well? So I ordered the bricks for 3 of these towers, one for OWASP themselves, one for the lead for the multi-user project, and one for us. The bricks tally up about 300 euros. You can just order them online on Bricklink. You might want to put some decent Raspberry Pis in there and buy a good power over Ethernet switch, some cables and stuff. That'll cost you about 1,000 euros, maybe a little bit less, and you can build it yourself. Again, this is a OWASP project. The instructions are Creative Commons, and yeah, that's that. Now we've saw a lot of projects. I lost count. If anyone knows how many projects that we saw, please let me know. But let's start. Let's start simple. And with simple, I mean we've saw all of these scanning tools. The most important thing to keep in mind when you start with scanning your code or scanning your applications is start measuring. Don't just say we're going to block anything that's not secure. Just start to measure and start simple. Start with a few rules. And once you see that you adhere to that rules, slowly start adding extra rules. And if that goes well, start adding quality gates in your pipeline that stop the pipeline when something bad happens. Because if you do that at the beginning, you will see that for months you will not release to production. Introduce these tools team by team, preferably, and start with the front runners. So start with teams that already have a very good focus on quality. Those teams can be the example of other teams to start using those tools as well. And most importantly, automate with those tools. Automate in your pipelines, because you don't want to sit down and run all of these tools manually each day or each week. And obviously we've got CI/CD pipelines, so plug in your tools there. Now we've got that software development lifecycle again. If you're not already doing dependency check with either OWASP dependency check or one of those other tools, please start doing that. You don't want to be the next guy that spends his whole weekend or Christmas fixing the next log4shell. And I promise you there will be a next log4shell. It might not be log4j, but it will be another library. If you have that in place and you're coding, you can use the relevant cheat sheets. You're probably doing Java development, maybe some front-end development, API development, or some Docker container development. Use the relevant cheat sheets to get some best practices in place. Now, I hope you're also doing peer reviews of your code with your colleagues. It's not about trusting your colleagues on writing quality and secure code. It's about verifying. So the OWASP code review guide is helpful as well in that, once again, take the appendix, take the checklist first, if you want to, sure, go ahead and read all of those 200 pages, but use the appendix, the checklist first if you want to get started. Then, if you want to go and do threat modeling, once again, the threat modeling tool to use is OWASP Threat Dragon. You can also use the OWASP Cornucopia card game to help you with a threat modeling session. Do know that this is not a I'll do it once and then I'm finished thing. This is something that you have to do regularly. Don't expect to do this once and threat model all of your risks. Then for security requirements, you can use the OWASP ASVS. This standard is meant to be forked and customized by you or your team. It will help you actually define requirements before you start to code. Then when you have all of these tools running, you can start aggregating them in Defect Dojo. If you want to start measuring your maturity, then I would suggest starting with the DevSecOps maturity model, not the SOM. You could do that as well, but then I would focus on the implementation and verification domains first. But DSOM is much more aligned with developers and more focusing on technical aspects. Now, if you're creating SBOMs and want to have a more wide view on your vulnerabilities, you can aggregate your results into dependency track, and you can keep an overview, and hopefully, and you will be able to real-time view your dependencies for all of your applications in one tool. That's called dependency track. And then it becomes fun because with OWASP ZAP, you can actually start hacking your application. Obviously, very important. Do this on a safe environment, not on production, obviously, not on acceptance. Maybe start doing this locally, maybe even for the first time, start doing this without internet or Wi-Fi enabled. So that's that. And to top it off, one more OWASP projects to rule them all. The OWASP Integration Standards project has a number of documents. One of them is the Application Security Wayfinder. This page on the OWASP site has most of the OWASP projects that I talked about on their page, and it outlines them in specific phases through your software development lifecycle and says and indicates which projects from OWASP are relevant in that stage. So basically, this is in one slide my presentation, sort of. There is also in the OWASP integration standards the opencre.org project, which stands for the Open Common Requirements Enumeration Project. This project connects a number of standards, both OWASP and outside of OWASP together, and connects relevant standards and items on those standards together. And there's a document called the OWASP in the software development lifecycle, how to plug in security in the software development lifecycle. That was my presentation. Thank you for listening. I hope you had a great time at jfall. If there are any questions, I'm not sure how much time we have left. I think we have a few more minutes left. Thank you.